All right, we're going to go ahead and begin lesson 7.1. And in 7.1, we're going to start with some definitions. And we're going to, if you notice, over there on the right side is a circle for each definition. So we're going to write the definition, and then we're going to draw an example of what this definition means. So the first thing we're going to talk about is Chapter 7 is, or Unit 7 is all about circles and how to find not just the circumference, which is, the perimeter all the way around, but we're going to talk about different things inside the circle and some different properties, okay? So I apologize that I don't have my stylus, so my handwriting might be a little off. So we're going to start with the definition of a circle is a set of points equidistant. Equidistant, we've talked about before, means equal distance. Equidistant from a given point called the center. And really, there's an infinite number of points around the center of the circle. Okay, so the circle is a set of points that are all equidistant from the center. So if I go over here and I call this center and make my point, I'm going to call this P, capital P, and that's how we name it, with a capital P. So this would be called circle P. You name it with the center. Notice that don't draw this, but all of the points, all the edges of the circle are all the same distance away from the center. Okay? So that's equidistant. The second we're going to talk about is a radius. A radius is a segment with endpoints at the center and on the circle. So radius it's a segment whose one endpoint is on the center and the other endpoint is on the circle. So if we go over here and we say again that this is circle P, the radius has an endpoint on the center and an endpoint on the circle. And I could call this maybe A out here. So the radius here would be segment AP. That would be my radius. Okay. The next thing is a chord. A chord is a segment with endpoints, both endpoints, on the circle. A segment with both endpoints on the circle. So I might have something that looks like this. J, K. So I know that this would be a chord with segment JK if I labeled it. Okay? The next definition is a diameter. And I think some of you already know what diameter is. You would say it's the inside length of the circle. But more specifically, the diameter is a chord. And remember, we just talked about a chord is a segment who has both endpoints on the circle. So it's a chord that passes through the center. That passes through the center. Something else to note is it is always twice or double, we'll say always double, the radius. So we know radius goes from the center out to the circle, and a diameter goes all the way from end to end, and it goes through the center. So the diameter is a chord that passes through the center. So remember, chord has two endpoints that are on the circle. The diameter goes, notice it goes through the center here. And so we could call this diameter A, B. It goes through the center, and it has endpoints that are on the circle. So this would be diameter, and the segment is AB. Remember the radius that we talked about. The radius is half of the diameter, right? So our radius, I'm trying to change my color around here. Half of this is the radius, okay? And then the whole thing is the diameter. And we'll be using that property a lot. Okay, next one we will say is the secant. And secant is a line that intersects a circle in exactly two places. So it's a line that intersects the circle in exactly two places. It doesn't have to go through the center. So we could say it's going to intersect here, and if I drew a line like this, it's touching here. But this is just a segment. Remember, a line continues to go on, and it has arrows on the ends. And so we would call this maybe point X and point Y over here. So this secant is line XY. Okay. Then a tangent is similar, but a tangent is a line that intersects a circle at exactly one point. One point. So the diameter intersected at two places. I'm sorry, the tangent, whoa, let me back up. A secant intersects at 2 points. The tangent intersects at 1 point. So it looks something like this. I'm going to draw this point over here. I have a line that just barely touches the circle, and it only touches at 1 point. And I would maybe call this, I could draw a couple more points on here. I could say that this is P, Q, R. So that line, PR or QR, remember you can name a line with any 2 points. That line is tangent and only touches the circle one time. And then point of tangency is the point where it's tangent. That seems pretty common sense, right? It's the point where the tangent line touches the circle or intersects the circle. So the point of tangency is the point where the tangent line touches the circle. So if I draw the exact same thing, here's point Q, P, R. My point of tangency is, it's going to be point Q. Okay, that's the one, that is the point of tangency. That's the point where it's touching the circle. Okay? All right, let's go to the next page. I know that definitions are not always super fun and exciting, but this is really going to set the tone for us as we continue to go through and learn about different parts of the circle, and you're going to want to refer back to these definitions in order to do your homework for today, okay? So a central angle is an angle with a vertex. Remember, vertex is the starting point, with a vertex on the center. With sides, two sides that are radii. Now that's a new word, radii. Radii just means the plural of radius. So a central angle is an angle with a vertex that is on the center, and two sides are the radii. So if we look back at our drawing, we're going to go ahead and do circle P again. So the center is P, and I'm going to draw an angle here that looks like this. I'll call this point A, this point B. So this angle that I have created, that is called a central angle. Notice the vertex is at the center of the circle. Okay, so we could say that this is angle APB. We could also say that this is angle BPA. So the thing that's important to note here is that the vertex is on the center. Okay, the vertex is on the center. That word on is going to be critical. Because an inscribed angle is an angle with a vertex that is on the circle, not the center. It is on the circle with two sides that are chords. Okay, so an angle with a vertex that is on the center, on the circle. So that's going to be the key thing here. The vertex is on the circle with two sides that are chords. So that might look like this. This vertex, I'm going to call this point K, is on the circle. Here's one side of the angle. Call that point J. And this L. So this angle that I've created right here is called an inscribed angle. It is inscribed on the circle. Okay, so notice again the vertex is here on the circle, whereas the vertex in the central angle, it's in the center. And so I would say that this is angle JKL, or we could say angle LKJ. All right, let's talk about an arc, not Noah's Ark. That's spelled with a K. An arc with a C is a portion or a section of the edge of the circle and it is defined by two endpoints. Defined by two endpoints. So again, the arc is a portion or a section of the circle defined by two endpoints. So if we look at this over here, I'm talking about this section of the circle of the edge, and I could call that A and B. So this is an arc. It's a portion of the circle. So this would be arc AB. And the way that you name this is with the two letters and an arc symbol. And you have to make sure that it looks like an arc, not a straight line, because that means something different. Okay, so the symbol is just an arc above the two letters. Okay, next we have a minor arc. We're almost done. A minor arc and a major arc. So a minor arc is an arc with measure that is less than 180. Less than, you might want to capitalize that, less than 180. That's a minor arc. When we're doing a minor arc, we use two letters to define. So it's very similar to our example where it's just an arc. Okay, so we're only going to use two letters. It has to be less than 180 degrees. And just so that you know, 180 degrees in a circle, it's 360. So 180 degrees is going to be half the circle. So anything that is less than that, is considered a minor arc. Okay? So let's draw a minor arc. We'll start here maybe and go to here. And we'll call this S and T. So this is arc ST. Now even if you had other letters over here, if I had maybe P here and Q here, we can still say that ST, arc ST, is a minor arc. Would you also agree though that from P to Q, that's also a minor arc, right? So I know also that PQ happens to be a minor arc, okay? So if a minor arc is an arc with a measure that is less than 180, the deduction we can make is that a major arc, I think you guys are getting it, is an arc with a measure that is greater than 180. Okay, and then to label a major arc, instead of using two letters, we're going to use three letters to define. So a minor arc is less than 180. A major arc is greater than 180. So again, greater than 180 means it's greater than half the circle. Okay, so if I draw an arc that's greater than half the circle, okay, and I'm going to have P in here and M. So this would be arc P, and we have to go in order. Notice I don't have anything colored over here, right? I didn't highlight anything over there, so I can't say PMN. That won't make sense. I have to go in order. So P in, and then I go to M. So it's like directions. Go from P to N to M. Okay, so that's arc P and M. Okay. The last thing we're going to talk about as far as definitions is concerned is a semicircle. Okay, a semicircle is an arc with endpoints that lie on the diameter. And a semicircle always equals 180 because it's half of a circle. Okay, so again, endpoints that lie on the diameter, it is half of a circle. So if I were to draw this, we'll call this X. And if I knew, here's my P. Is my center. So notice the XY is the diameter. So XY is the diameter. And then I have semicircle X, and I need 3 letters, right? So I need another point on there. So we'll put point here. We'll call this point Z. And so if XY is the diameter, then this semicircle is semicircle, and we're going to name it with an arc, X, Z, Y. Again, we have to go in order. Start with X, Z, Y. We could also say, I hear some of you already asking this in your head maybe, you could say Y, Z, X. It's the same thing. Okay? All right, we're going to talk about a couple formulas that you're going to need, and then we'll get to work. So the area of the circle is everything that's inside of the circle. Okay, so the area covers the inside of the circle. So the area of a circle is equal to pi times r squared. R stands for the radius, right? R is the radius. And we know that pi is 3.14. Now, if in your homework it says exact, find the exact radius, what that means is you leave pi in your answer. Do not use 3.14 or the pi button on your calculator. You would just leave pi in your answer. If it says to round or anything like that, then you will use 3.14. Okay, so the circumference is the perimeter around the circle, around the edge of the circle. And their circumference can be written 2 ways. So the circumference can be written as 2 pi r, r being the radius, but if I multiply the radius by 2, I'm getting the diameter, right? Isn't the radius half of the diameter? So I could also say pi times diameter is the same thing as 2 pi r, right? Because again, if I multiply 2 times the radius, I get the diameter. So I can just take out 2r and put a d in instead. And then the d stands for diameter. I should mention when you're doing area, your answer is always in units squared. So units squared. Make yourself a note there that it's, if they don't tell you that it's feet or centimeters or meters or whatever, you can always just put units squared. Otherwise it's centimeters squared, feet squared, miles squared, whatever. Squared, because area is 2-dimensional. Circumference is not, it's just feet, meters, or what have you. Okay? And lastly, to find arc length, we're going to set up a proportion. Okay? So to find the arc length, which doesn't mean the degrees, so when we were doing the length up, or the measurement up above, arcs are always measured in degrees, okay? But if you want to find the length of the arc, which is like feet or inches or whatever, we have to work out a formula. So we're going to say the measure of the arc over 360, right? Because measurement is in degrees, equals the length, that's a lowercase l, of the arc, divided by 2 pi r, which is the circumference. Okay, so if you notice, measurement is in degrees, and so is 360. Length and 2 pi radius is going to give you measurement, so like feet or centimeters or inches or whatever. So notice that degrees go with degrees and length goes with length. Okay, these are going to be really important formulas for us to know. Okay, for this name that circle part, I want you to get with a neighbor or a partner, and I want you to do 1 through 20 with a neighbor or a partner. You have a word bank right here where it says parts of a circle. Okay, these words are going to be maybe used more than once, and you have all your definitions on the previous page. Your diagram is up there. I want you to name the parts of the circle that go in the blanks, okay?